Welcome back.
Welcome back for Astronomy in the News. I am Brian Mulligan, also known as AstroBit.
And I am Sinclaire Manning, also known as Major Merger. And here are this month's top news stories in astronomy. So first up, for the first time, astronomers have detected helium in the atmosphere of an exoplanet, which is a planet that orbits a star other than our sun. This discovery shows that it's possible to probe the makeup of the atmospheres of some exoplanets without the use of expensive new space telescopes. So everyone crossing their fingers for JWST, it's actually okay. We can still do science. So PhD student Jessica Spake at the University of Exeter in England was the... Oh, wait, someone from England in the house. She was the lead author of this recent paper. And to observe exoplanet atmospheres, she and her team must wait until the planet passes between its host star and the Earth, and then study the light from the star that passes as it passes through the exoplanet's atmosphere. So WASP 107b, shown here as an artist's rendition, is a super Neptune world about 200 light years from Earth in the constellation Virgo. It is a gas giant with a diameter comparable to Jupiter's, but having just 1/8 the mass of Jupiter, making it one of the lowest density worlds we know of. It orbits its host star once every 5.7 Earth days, and its average temperature is measured to be a balmy 932 degrees Fahrenheit.
Perfect out in summer.
Yes. So Spake used the Hubble Space Telescope to study the planet in infrared wavelengths, which you all just learned a lot about from our previous talk. But having success at these longer wavelengths is promising for the field, as it confirms that shorter UV wavelength observations aren't necessary for detections of these other metals in the atmosphere. So that means that we can do these observations from the ground, which is much cheaper and easier, as infrared light can more easily pass through the Earth's atmosphere and be observed.
All right, the Gaia team has released their second set of data, now providing information for about 0.5% of all the stars in our galaxy.
1%.
The Gaia satellite has been mapping the sky since 2014. Their first release occurred in 2016, but it included only the position in the sky of most of these stars. This release includes not only the position, but also the distance, brightness, motion of 1.7 billion stars. The information produced by Gaia will be used for more accurate measurements of the distance to other galaxies and bright astronomical phenomena such as supernova, which I study. Within our galaxy, Gaia's results will aid in producing a map of the structure of our galaxy, the location of dark matter, and will help identify the remnants of dwarf galaxies that have been swallowed by our galaxy in the last few billion years. This most recent data set has already been used to better understand the orbit and contents of the Sculptor dwarf galaxy, which is a small satellite galaxy to our own. Additionally, Gaia is providing very precise information about the position and orbits of asteroids within our solar system. Over 14,000 asteroids were included in this most recent catalog. If you're interested in seeing the results for yourself, there's an app called Gaia Sky that you can download that allows you to view the parts of the galaxy that Gaia has already mapped. Gaia is expected to continue to operate through 2022, though if fuel and money are available and there's no failures aboard the satellite, the mission is very likely to be extended as well.
All right. So the search for extraterrestrial intelligence, or SETI, may be getting a reboot. So for the first time in 25 years, Congress is considering allocating a large sum of money to the organization as part of a bill that includes $10 million to NASA funding for the next 2 years to search for techno-signatures, such as radio transmissions, in order to meet the NASA objective to search for life's origin, evolution, distribution, and future in the universe. So Jill Tarter, shown on the right here, former director of the SETI Institute, told reporters recently that the funding proposal seems to be an extension of the efforts of Representative Lamar Smith of Texas to bring attention to the search for life beyond Earth when he was the chairman of the House Science Committee. The endorsement was particularly surprising. You know, but it was particularly surprising considering Smith is a known climate denier, human-caused climate change denier. So, you know, you win some, you lose some, I guess. Yeah. So while private companies and organizations have continued to fund the search for intelligence beyond Earth, having buy-in from the federal government again for the first time since 1992 would be a really big deal. So this is just an authorization bill, though, so even if it passes, SETI may not actually get any funding in the actual appropriations bill, but Tarter is excited by the potential funding and hopes in the future that there will be an international endowment for searching for intelligent life beyond Earth.
But not in the White House.
No. Burn.
All right. So a team led by Stuart Ryder used the Hubble Space Telescope to find the surviving companion star of a supernova, providing confirmation for the cause of this particular type of supernova. The light from supernova 2001 IG first reached Earth in December 2001. You can see an image, the nice, let's see, yes, the nice bright obvious thing right there. Is that right? No, actually, I think it's the thing off to the side there. I think the really bright thing is the galaxy. It was, let's see, it was identified as a Type 2b supernova, which is the result of a massive star that's reached the end of its lifetime and run out of fuel, resulting in an explosion. It's somewhat unusual in terms of supernova in that the evidence for the hydrogen in the explosion fades over the first few weeks that you can see the supernova. This suggests that the progenitor of the explosion has less hydrogen in its atmosphere than is expected for most stars. The explanation is that those types of stars have a companion star that kind of steals away much of the atmosphere and hydrogen before the star explodes. In 2016, Stewart's team used Hubble to take images of the region in which this explosion was seen and found a single object, which you can see right there, that bright spot there. They found this single object that appears to be a massive star in the place where the supernova occurred. Their observations combined with models suggest that the companion was about 9 times the mass of the Sun, while the star that exploded was about 14 times the mass of the Sun. This is not the first time such a detection of such a companion has been, such a detection has occurred. But the relative isolation of this companion means that it's a much clearer picture to be sure that that is actually a companion to the supernova and not to some other star that happens to be nearby in that same area. Because the remaining star is so massive, it's also likely to explode in about 30 million years. No word yet on whether NASA is providing funding to watch for that event.
Okay, so a recently discovered galactic proto cluster known as SPT-2349 has taken over the top spot for most massive object in the galaxy, or in the universe. Not the galaxy, in the universe. So an object, as defined in astrophysics, is something that is bound together by its own self-gravity. So objects exist on an extremely broad range of masses, from planets to stars, to collections of stars orbiting within a galaxy, and then going a couple steps further, galaxy clusters are objects made up of many galaxies, all orbiting around their center of mass. So Scott Chapman is an astrophysicist at the Dalhousie University in Halifax, Nova Scotia, and science lead of the team who discovered the proto cluster. And fun fact, Scott is also my academic grandfather, which is a thing we have, meaning he's the advisor of my advisor. And you can trace your whole academic family tree if you care. My academic brother just gave a talk. We have the same advisor, and it's like sweet and meaningless, but whatever. So Scott says that they hit the jackpot with this structure. More than 14 very massive individual galaxies are crammed into the space of something not much larger than our own Milky Way. SPT-2349 exists when the universe was just 1/10 of its current age, so about 1.4 billion years after the Big Bang. And eventually these galaxies will all merge into one gargantuan galaxy. Further observations have revealed that the total structure contains around 50 additional galaxies all orbiting around this central massive structure. And the previous record holder, appropriately named El Gordo, I know it has a much more interesting, they're coming up with a more interesting name, I think, soon. But El Gordo contained a mass equivalent to 3 quadrillion suns. But SPT 2349 may outweigh El Gordo by at least 4 or 5 times. So this thing is really, really massive. This protocluster is particularly interesting as well, as it was previously thought that such massive structures could not form so early in the universe based on current computer simulations. However, astronomers have only been able to search a small fraction of the sky for these objects, so there may be many more out there just waiting to be discovered.
All right, finally, our last story is Astronomy Not in the News. It's a segment where we highlight a story that has generated a lot of discussion within the field of astronomy, but it hasn't necessarily made it into the mainstream news. So this month's story is about research done by a team led by Sarah Ellison, who looked at galaxies that have merged and found that these galaxies don't stop forming stars because they run out of gas, as was previously expected, but instead the gas becomes too turbulent to form more stars. The team used data from the Sloan Digital Sky Survey combined with recent observations from the Arecibo Radio Telescope in Puerto Rico to explore how much gas is found in galaxies that have recently merged. They found that there's more gas than expected within these galaxies, and since free gas and dust are required for stars to form, this suggests that the galaxies should have plenty of fuel available to continue forming stars, meaning something other than lack of gas must be responsible for the end of star formation within these galaxies. They propose that the turbulence induced within the gas by the merger itself has enough energy to prevent the gas from coalescing and thus slowing or stopping further star formation. That is all we have for Astronomy in the News for May 2018.
Thank you very much.
Thank you all for coming, and enjoy the rest of the show.